Good morning, and let's get started. So I'm just gonna go to Notability, and I'm just gonna go in the order that the questions are in on Ln Kappa. So, question number 1, calculate the concentration of H+. Calculate the concentration of H+ for this solution. So what you're going to do is you want to write your formula first. This is the one that's in my question. O2 plus water goes to H3O plus C 4H7O2 minus. Okay, and now we have to do our ice table. It gives us the initial of this acid in the question, so that's 1.00 times 10 to the negative 3. That's just for me. These are 0. Water's never included. And then for change, we have negative x plus x plus x. So here we have 1.00 times 10 to the negative 3, x and x. And then we have Ka equals x squared over 1.00 times 10 to the negative 3 minus x. Our Ka is 1.40 times 10 to the negative 5. Since our Ka is super small, we can disregard this x, so we have Ka equals x squared over 1.00 times 10 to the negative 3. We know Ka, it's 1.4 times 10 to the negative 5 equals x squared times 1.00 times 10 to the negative 3. And now we just solve for x. How we solve for x is we multiply these two, cross multiply, and then square root to get rid of the x squared. And then we get x equals, let me just do that. It's 1.12 times 10 to the negative 4 molar. And as you can see here, x is the concentration of H3O plus, and the concentration of H3O plus is the same as the concentration of H plus. So that's our first part of our answer. Now for the second part, to find pH. pH equals negative log concentration of H plus equals negative log of that. And when we do that, we get 3.953. Okay. Question 2. An aqueous solution of monoprotic acid. So it's asking for the molarity of the solution. HA plus A minus. So if an aqueous solution of HA plus water goes to A minus plus H3O plus. And what are we given? We're given pH equals 4.64. H3O plus. We are not given that. And we have Ka equals 2.53 times 10 to the negative 2. Okay, ice table. Just give me 1 second. I don't think we did an ice table here. Okay, here we do not need an ice table because we can find the concentration of H3O plus from the pH. And when we find that number, that's already going to be the equilibrium number. So we don't need to do an ice table. So concentration of H3O plus is 10 to the negative of pH equals 10 to the negative 4.64, and that's going to be 2.29 times 10 to the negative 5. And now that we have this 2.29 times 10 to the negative 5, it's molar. Since it's a 1-to-1 ratio, this is also the exact same thing because it's 1-to-1 ratio. And now we need the concentration of HA, because remember the question is asking for HA plus A minus, okay? And we already have A minus, we found it here, because it's equal to H3O plus. To find the concentration of HA, we can use a Ka expression. Ka equals H3O plus times A minus over HA, and then we rearrange this to get HA equals H3O plus times A minus over Ka. And once you do that, solve for x. Whatever you get here is your answer. I'm tripping. Once you get this, sorry, I don't have it written down. That's why. Whatever you get here is going to be your HA, and then your final answer is this, HA plus A minus. So whatever you find here plus this number that you calculate. Okay, number 3. Calculate the pH of this solution. So H2SO4 plus H2O goes to HSO4 minus plus H3O plus. If you look at this question, it gives us the Ka of HSO4 minus. So Ka for HSO4 minus is 0.0120. Nowhere in this equation do I have HSO4 minus. So that means I cannot use this Ka for this equation. I need to write a new equation, which is HSO4 minus. Sorry, actually, I do have HSO4 minus here, but it's actually acting as the conjugate base. Therefore, I cannot use Ka for it, so I need to write a new equation where it's acting as the acid. Okay, now in this equation, I can use this Ka because HSO4 is acting as an acid. So now, from my first equation that I wrote, I'm just going to call this equation 1, this is equation 2. For my first equation, H2SO4 plus H2O, we have to do an ice table. So this one, concentration of H2SO4, it's given in the question, 9.31 times 10 to the negative 3, 0, 0, minus x, plus x, plus x. Then we have 9.31 minus x, times 10 to the negative 3 minus x, and then x, and then x. Right? That's our ice table. And we need to find the x, but so in this equation, if you look here, if you look here, this equation up top here, it gives us a strong acid. Whenever an equation gives us a strong acid, that means it's 100% dissociating. Therefore, there is no equilibrium here. It's just a one-way reaction due to the strong acid. Now that we know that, it's 100% dissociation, so it just goes one way. So at the end of this equation, there's going to be none of H2SO4 left. That means the equilibrium concentration of H2SO4 is going to be 0. There's going to be none of it left. Therefore, our X is 9.31 times 10 to the negative 3, because we have to get rid of all of this. So there we go. That's our X. Okay. And now that we have that, we're going to leave that for now and go to our second equation. HSO4 minus plus H2O. SO4 minus plus H3O plus. Second equation. And we need to do an ice table for this one as well, right? Ice table. Initially, we have 9.31 times 10 to the negative 3 of HSO4 minus. This value right here, it came from right here. We calculated it, right? HSO4 minus, HSO4 minus. Then this is 0. And this H3O plus is also 9.31 times 10 to the negative 3, again, from right here. Okay, now that we have that, this one, oops, I wrote the wrong thing here. This should be minus x plus x plus x. So we have 9.31 times 10 to the negative 3 minus x, 9.31 times 10 to the negative 3 plus x. And if you look here, our Ka is right here. Our Ka is too big to assume x is small. So here we're going to have to use quadratic formula. Products of reactants, and you just use Wolfram alpha or quadratic formula, and when you solve for x, you get a number. Okay, now that we have x, right, we need to find the pH of this solution, and pH is negative log of H3O plus, and that's going to be to find this part, negative log, to find the concentration of H3O plus, you have to add this H3O plus and oh yeah, you just have to put that here. And yeah, that's your pH. Okay. Question number 4. This one is percent dissociation. So for this one, we have a monoprotic acid. A monoprotic acid just means HA. So we have concentration of HA is 1 times 10 to the negative 2. And that is 32.7% dissociated. Okay. So now we have HA plus H2O goes to H3O plus A minus. And then we have 4.2 times 10 to the negative 2, 0, 0, minus x plus x plus x. And then we have to the negative 2, x, x. Okay. We have our ice table. And solve for x. X is going to be equal to 32.7% of 4.2 times 10 to the negative 2. Because this monoprotic acid is 32.7% dissociated. That means 32.7% of it is released in water. So that's how much is going to be changing from the concentration. So all I have to do is calculate 37.7% of this number, and that happens to be 0.0137667. And how to find percent of something is turn the percent to a decimal and then multiply by the number. Okay. Now that you have x, you have all your equilibrium concentrations, right? So we can solve Ka equals x squared over 4.21 times 10 to the negative 2 minus x. And yep, that's what you need, Ka. Okay. Question 5. Calculate the concentration of OH. Okay. So we have HONH2 goes to H2. Okay, and it gives us the initial concentration of this one. And then this is going to be minus x plus x plus x. Okay, and then we need to write a Kb expression because this is basic solution, so we're using Kb now. Kb equals x squared over 5.01 times 10 to the negative 1 minus x. Kb is given. Kb equals 1.1 times 10 to the negative 8. Since Kb is so small, we can disregard this minus x. So we have 1.1 times 10 to the negative 8 equals x squared over 5.01 times 10 to the negative 1. And when we solve for x, we get 0.0063158. And then that is the concentration of OH minus. Sorry. I was looking at the wrong question. This is not x. This is x, 7.42 times 10 to the negative 5. Okay, and x is concentration of OH minus. So there we go, done the first part. Now we have to find pH. Since we have concentration of OH minus, first we have to find pOH. pH can only be calculated from H3O plus. We do not have that, we have OH minus, so first we find pOH, which is negative log of OH minus, and that's going to be 4.13, and pH plus pOH equals 14, so pH equals 14 minus pOH, so pH equals 9.87. There we go. question 6 now. Question 6 is the exact same as question question 6 is the exact same as question 5. It's the exact same. The only difference here is since KB here is 1.3 times 10 to the negative 3, you cannot assume that in your KB, you cannot assume that this x is irrelevant because the KB is too big. So you just have to use quadratic formula for this one. That's the only difference. And then once you have x, you just do the exact same stuff as right here. Okay, number 7. Okay. So we have to calculate the pH. So we have H2NNH3. We have H2NNH3Cl, but the Cl is like irrelevant because it just dissociates out. So I just write H2NNH3 plus H2O. Okay, so here we are given the initial concentration of this one, 3.70 times 10 to the negative 1 molar. And we are also given KB. We are given KB. But here we are producing H3O+, so KB is useless to us. We need to find Ka. How to find Ka from KB is Ka equals Kw over Kb. So Ka, and also Kw is always 10 to the negative 14. Okay, so our Ka is going to be 3.33 times 10 to the negative 9. And then now we just do our ice table. You know the drill, and then I'm just not going to write the last part. And then we have Ka equals x squared over 9.7 times 10 to the negative 7. We don't need this minus x because our K is super small. And then we just solve for x. X is going to be 5.69 times 10 to the negative 5. And that's our concentration of H3O+, right, from our ice table. And now we need to find pH. pH is negative log of H3O+, and that's, I don't have the number here, but yeah, whatever you get. Oh yeah, sorry. 4.25. For number 8 is the exact same as number 7, except you are given Ka, and you have to turn that into Kb, and that's Kb equals Kw over Ka, and then it's asking for the pH. So once you in this equation, you're gonna have you're gonna have C3H5O3 plus H2O goes to H3H5O3 plus OH minus. As you can see here, we have a basic equation. It has OH minus, which is why we need that Kb value, right? And then, since we have that OH minus, once you solve for X here, you're going to get concentration of OH minus. That's what X is going to be. And then, that'll give you POH equals negative log of OH, and then pH equals 14 minus POH. Okay. Now for number 9, I don't know. I have to go to office hours. Number 10, I also don't know. Have to go to office hours. Number 11. We have CaClO4 We need the pH of this. So CaClO4 is going to dissociate into Ca2+, which is neutral, and it's going to dissociate into ClO4-, which is also neutral. Since both are neutral, the pH is going to be 7.00, because pH of 7 is neutral. Sorry, that's wrong. So yeah, this first part is right. It's going to first dissociate into Ca2+, which is always normal. Any like ion is always neutral. So yeah, like these would both always be neutral. And then we have ClO4-, and we want to see what that's going to give when we add H2O to it. And that's going to give HClO4, which is a strong acid. And then it's also going to give OH-, which is a strong base. And since this is just neutral, and then this is a strong acid, strong base, it's also neutral. So yeah, pH is 7.00. Okay, now a pH salt basic, number 12. We have LiC2H3O2, right? That's going to dissociate into lithium plus, which is neutral, and C2H3O2 plus H2O goes to HC2H3O2 plus OH-, and then it gives us the initial of this one. This is 0, 0, minus X, plus X, plus X. Okay, now we're going to have our Kb equation. It's Kb because we have OH- here. And then we have X squared over 0.72, right? And the question gives us Ka, but we need Kb, so we do Kw we need Kb, so we get Kw over Ka. So our Kb is going to be 5.56 times 10 to the negative 10. Since K is so small, that's why we don't have this in minus X. And then, we have Kb, and then once we have Kb, you plug it back into here, and then you solve for X. X is 2.00 times 10 to the negative 5. We need the pH. Remember, first we have to find POH, because we're dealing with a basic equation here. pH is negative log of OH-. This X is the concentration of OH minus. And then once we have, that's 4.70. And then once we have pOH, pH is just 14 minus pOH, which is going to be 9.30. The next equation, number 13, is the exact same as this one, except it gives you KB, and you need to turn that into KA. Turn that into KA, so we're gonna do KA equals KW over KB. Remember, KW is always equal to 10 to the negative 14. And number 14, how you do it is you have to draw the Lewis structures of all of them. Lewis structures, and then which the Lewis base is the proton donor, whichever one gives protons away. And that is all.